Alright, what I'm wanting to do right now is just to get y'all acclimated with your trig ratios again, going back to trigonometry that you learned in geometry class a couple of years ago. Well, back then you learned 3 trig ratios. I'm going to be showing you 6. However, 3 of them aren't going to be exactly prevalent right now at this time. But I just need to kind of get you acclimated with them to understand where it comes from. But we'll be doing some more work later. So what we're doing here is we're going to be solving right triangles. And in any right triangle, there's always a special relationship between the legs and the hypotenuse. So it doesn't matter what the acute angles are. The acute angles, every 30-degree angle has a special relationship between the side opposite it and what's adjacent. What's adjacent and the hypotenuse. If this was a 32-degree angle, every 32-degree angle in a right triangle has the same ratio relationship. So for that reason, we can solve right triangles by setting up proportions. All right? And so the first 3 trig functions that you used were sine, cosine, and tangent. And I write those out because I don't want you to name them by their abbreviation. I don't like you to say sin, cos, and tan. So I need to make sure you understand the full term. All right? And so when you're talking about sine, cosine, and tangent, we're talking about if you have an angle, and we're going to call that angle theta. All right? Theta is kind of the generic term for the angle that we're referencing. If I'm using this angle, the side across from it is going to be considered my opposite side or leg. The side adjacent to it is known as the adjacent side or leg. The hypotenuse, although it is adjacent, is not a leg. Hypotenuse is always across from the right angle, and the hypotenuse is never considered an adjacent side. Also, we only write trig ratios using our acute angles, so never use your right angle. So with that being said, let's go ahead and make a note. Theta is, we'll go ahead and name it out here, theta is the angle of reference. And I say of reference because it's our starting point. You have to have a starting point. Always use an acute angle as your reference angle. And it doesn't matter which one you use, but you've got to pick one of them, okay? One of the two. And that's how you determine which trig function to use. So now, if I use sine, I've got to use my opposite and my hypotenuse. If I use cosine, I have to use my adjacent and my hypotenuse. And if I'm using the tangent function, then I need my opposite over my adjacent. So these are the rules, basically, or the function rules that you're going to be using for sine, cosine, and tangent. Now, the other 3 that we use, that you'll be using later, are the reciprocals of these main 3. Sine's reciprocal, and this abbreviation stands for cosecant, is just the reciprocal hypotenuse over the opposite. Cosine's reciprocal is secant, and tangent's reciprocal is cotangent. And just to make note that these 3 are reciprocals. These are reciprocals of original 3. But these are the ones we're going to be using right now for problem solving. Now, you may remember from geometry, one way to get you to remember your trig ratios is to remember the term SOHCAHTOA. TOA. This is your sine ratio, is opposite to hypotenuse. Your cosine ratio is adjacent to hypotenuse. And your tangent ratio is opposite to adjacent. So as long as you can spell that out correctly, you're in good shape. Now, what we're going to do is just practice getting our trig ratios. So down here, we've got a right triangle, and you're asked to find the sine, cosine, tangent, secant, cosecant, and cotangent ratios for angle A. Well, that means angle A is our theta. It's our point of reference. That's where we're starting. All right, so we've got, so if you want to put a theta symbol there, you can to help you. So we've got two sides. We've got this side that has a length of 10. I want you to note that it is opposite angle A, so we're going to put opposite there. 8 is the one that is adjacent to it, and the side we don't know is the hypotenuse. Well, what we're going to have to do is find the hypotenuse, and we've already practiced Pythagorean theorem, and we know that a squared plus b squared equals c squared. So we're going to say 10 squared plus 8 squared equals c. And now, one thing that I'm going to have y'all do is practice working with exact numbers. So this is the square root of 164. And 164 can be broken down into 4 times 41. And the reason why I broke it down into those numbers is we are trying to simplify the radical. So we got to find a perfect square factor. 4 is your perfect square factor. The square root of 4 is 2. And 41 is not a perfect square. It's prime. Can't be simplified, so we leave it under the radical. So I want you to use the value 2 root 41 for the hypotenuse. All right, now to write our ratios out, this is how it's going to look. We've got your sine of A, your cosine of A, and your tangent of A. Your sine of A, we need to go opposite to hypotenuse. So it would be 10 over 2 root 41. The cosine of A is adjacent to hypotenuse, so it's 8 over 2 root 41. And our tangent ratio, opposite to adjacent, 10 over 8. Okay, now we will need to simplify this and rationalize the denominator, but I'm going to get the, I want to go ahead and do the other 3 before we take part in that. So the other 3 are reciprocals. So we have the cosecant of A, the secant of A, and the cotangent of A. The cosecant of A is the reciprocal, so we have 2 root 41 over 10. The secant is 2 root 41, 2 root 41 over 8. And our cotangent is 8 over 10. Now, I'm going to simplify these right away. We just reduce down, take out the common factor of 2, and we have root 41 over 5. We have root 41 over 4, and we have 4/5. Now that I have those reduced, I'm going to come back over here, and I'm going to simplify these. My reciprocal is 5/4. Here we would have 4 over root 41. Here we would have 5 over root 41. Now, the problem is we have a radical in the denominator. If I'm going to leave this answer as such, I need to eliminate the radical in the denominator. We call that rationalizing. So you want to be able to rationalize and reduce. We've already reduced. To rationalize, you're going to multiply the denominator times itself. When you do that, you create a perfect square. And when you create a perfect square, you eliminate the radical. But I have to multiply the numerator and the denominator by the square root of 41. And when I do that, I'm going to end up with 5 times 41 in my numerator, or I'm sorry, 5 times root 41, and then 41 in the denominator. Do the same thing with your cosine, so that's going to end up being 4 root 41 over 41. Now, I realize that looks like a really ugly number, but I need to get you acclimated to leaving your answers in an exact form and not round it to the nearest tenth place or something like that, because there are going to be times when you have an ugly radical, but when you use it, continue to use it in a problem, everything works out and you get a nice, pretty, even answer. All right, so now then, with this second, and I know there's not a whole lot of room, with this second triangle right here, I want you to first find your hypotenuse. So we've got your 4 squared plus 10 squared, all under the radical. That's the square root of 116. And I just take my calculator and I start dividing by perfect squares to see what happens. And I used 4 because this looked like it could be divisible by 4. And it was, and I got 29. So therefore, when I simplify and take out the perfect square factor, I've got 2 root 29. And this is going to be the same type of situation where we go ahead and write and simplify all of the trig ratios. I'm not actually going to do that. However, you're welcome to do it if you need the extra practice, and then I have my answer key posted so you can check your work with that. All right, let's check down here now with number 3 and 4. Actually, these problems are exactly like these. The difference is here I gave you a picture with the information. This I gave you a function rule, an equation with the information. So you've got to be able to look at this and say, well, if I've got a cosine of an angle and the ratio is 5 to 13, and I know my cosine ratio is my adjacent over my hypotenuse, then I'm going to draw out a triangle, a right triangle, and note my hypotenuse is 13. And I don't care where you put angle A, but wherever you put it, the side adjacent to it has to be 5. So that's the important part. You can find your third side, again, doing Pythagorean theorem, but this time I've got my hypotenuse, so we've got 13 squared minus 5 squared. That's going to be 144, and the square root of 144 is 12. So we've got a nice even answer right there. So those are my side links, 5, 12, and 13. You are asked to find the rest of the trig ratios with that. So what we're going to do is we're going to start with sine of A. We've got cosine. Then we'll do the tangent of angle A, the reciprocal of sine, which is cosecant, the reciprocal of cosine, which is secant, and the reciprocal of tangent, which is cotangent. And we're going to say my sine ratio, if I start at this angle, this is my reference angle, I have to go opposite to hypotenuse, 12 to 13. My tangent ratio, opposite to adjacent, that's 12 to 5. My cosecant, it's the reciprocal of cosine, so I'm just going to flip the 13 and the 12. Secant, it's the reciprocal of cosine, so this will be 13 to 5. And cotangent, it's the reciprocal of tangent, so it's 5 to 12. All right. Now, that is all 6 of our trig ratios that we needed to practice on, just getting acclimated with our positions and where these sides are in relationship to the angle that we're using. Number 4 is the exact same type of problem. I'm not going to do the whole thing, but I do want you to go ahead and solve to find the missing side. Because we have a radical, I want you to see that you do everything still the same way. Since this is our sine ratio, sine is opposite to hypotenuse. So if I were to draw my right triangle, I know my hypotenuse is 6. My leg is root 11, and it's opposite the angle. So this time I'm going to put my angle over here because I have to draw it across from the side that I know. Do Pythagorean theorem to solve for the missing side, and that is going to be your hypotenuse squared minus your leg squared. And when you square a radical, don't forget you're undoing that radical. So this is really 36 minus 11, which is 25, and the square root of 25 is 5. So our missing side over here is 5, and you would go through the process of setting everything up exactly the same that we did over here. All right. That is the main thing that I needed you to learn from this lesson, is to make sure you understand that when you're writing a trig ratio, you have to have an acute angle to start with. Pick one. Either one. Whichever one's easiest, if they give you an angle, whatever the case may be, but you have to start with an acute angle, and then you have to be able to identify your ratio that matches your sine function, or your trig function right here. It always helps to write out the name, acronym SOHCAHTOA, because that helps you get everything set up so that you can write all your functions. Okay.